Thanks, everyone. Thanks, everyone. So we are almost at the end of this conference, and again, another AI presentation. But this presentation will not be just about AI. I arrived here in Thessaloniki on Wednesday, so I had some time to sightseeing. So we have the Arc of Galerius, White Tower, and Rotonda, which means a roundabout in Italian. Fine. But then I didn't came, of course, just for this. I also came for food. So we have pita and gyros. How am I going? Okay, so I think we can start. And who am I? I'm Francesco, developer advocate at DDDev. I'm very active on YouTube and Twitter, X. Sorry, I didn't have time to change them. And I've been working here as a developer advocate for about 3+ years. What's the agenda for today? So first of all, I want to make a quick thought about how we can have the idea to find the process for a project. And then we'll talk about the tools that I used to build this up. We'll see the project together. We'll check the code, of course, and explain what it does. And at the very end, there is a final little surprise, okay? Just a quick thought about AI. I think AI changed us. We can say also this from all the conference presentations, also the presentations before mine. It was very insightful. And just a quick thought, I think that one question that we can try to answer is that is all of this wrong? Like I know many people, they think that AI is like the evil, that it's we should not use AI or not. I don't know which is the right answer here. I think that AI can be very useful to build things, but I think the only tip that I would like to give is that we should always understand what is going on under the hood, otherwise we lose control of our applications, what we are doing, and so on. So how can we find an idea for a project? When I submitted this talk some months ago, I didn't have an exact idea of what I want to build. I want to say, okay, maybe I want to use Rust, which is a language I like, Docker, but I don't have an idea. So how can I find the good idea? By the way, I got the idea during a conference, and I will start with the problem. Or even better, a problem that I have. So I tried to find a tool that could solve one of my issues, and my issue, it was to have a tool that can make real-time captions, but not like this one, but translating in real time. Do you know any tool that does this? No. Okay, good for me. Because maybe by the end of this talk, I will show you something cool, or maybe not. By the way, I don't have any backup video, so this might also fail very hard. So the problem is to make a live event like this one, and having in my own language, and then being understood by the audience, okay? How many people are from Greece here? Okay, so we can make the test in Greek, perfect, thanks. Okay, so let's start with technologies that I liked. What is Rust? How many people have ever used Rust as a programming language? Make me proud. Nice, great. So I try to convince the rest of the people now. So what is Rust? Okay, the definition is that Rust is a compiled programming language that is used for safety, concurrency, performance. Very nice definition, but why? Why it might be interesting to know and explore more this programming language. Rust by default is a fast and powerful programming language, as are, for example, C, C++, and Go. So when a programming language is fast and efficient, it's always worth checking, I think, in my opinion. And it can be used used mostly for system programming, but web development. And this is where I really got interested into learning Rust and also teaching Rust, because I think that most of us here, I don't know, but I think most of us here, they made some APIs, they know the differences between backend and frontend, they built some applications, so maybe trying to do a web application using Rust, we just need to understand the syntax. So I think this is one of the reasons why it might be interesting to learn. This ecosystem might even grow in the future. Rust has also been the most admired programming language on the Stack Overflow survey in 2024. And also, some years ago, I was interested in blockchain development, so it's also used for smart contracts. Does anyone here write any smart contract blockchain development? 0. Okay, fine. A disclaimer. Rust is not beginner friendly, so even if this is against my interest, I have to say that probably it's not the best solution if you're just getting started with development. Also because many courses or many tutorials, they refer to other programming languages, so you might get frustrated if you keep hearing like, this is like JavaScript, this is like Python. We will use a web framework which is similar to Express. Do you know that Express now has the version 5? It has been released some days ago. I was shocked. It was 10 years that they were in 5 alpha. And now some killer features for Rust. I chose just 2 of them. The first one is this one. Rust doesn't have a garbage collector. What is a garbage collector? Is a system that basically cleans the memory in a program, just to make it easy. So some languages, they have a garbage collector. Some languages, they let you handle the memory manually, like for example, C. So it's a bit of a nightmare when we do this. And Rust is different from both of them. And it checks when needed. Of course, I'll be quick here. So if you're curious, you can check all the system of ownership and the borrow checker. But this is an interesting fact. I think in the future, we'll have more languages that are inspired by the memory management of Rust. And also because the Rust compiler is different, I would say. So we are used to see something like this. So when we have a problem in the compiler, we have this stack trace, and sometimes it's not that easy to understand the error. Instead, I consider the Rust compiler like an old grandma, so it's very annoying, but they really want the good for us. So, and usually, when at the end the program compiles, it works. For now, it always works for me. Another technology that I used a lot is Docker. I'm also a Docker captain, so I really like this. I've been liking this technology since 2015. How many people have ever used Docker here? Almost everyone. So, okay, I'll be quick here. Okay, so the idea, Docker basically is this platform to build applications and basically let you run them everywhere. And of course, we can use Rust with Docker. What is a container? I like these 2 definitions. One is from a logical point of view. So from a logical point of view, it's a single and packaged unit of software that does something. And from a technical point of view, it's an isolated Linux process. To be precise, is a process running in a single Linux process, container running in a Linux process. And you will never see a definition like this in the official documentation, but we can consider images like blueprints, like classes, and containers like instances of that class. This is just to have an idea. And an advantage of using containers is that we can work on different projects at the same time, projects that have the same software, for example, Postgres, but different versions at the same time, without having even to install them. I haven't been installing a database since 2016 and 2017. And there are, for example, for Node.js, we have something like MVM to switch between different versions. But for other programs or other programming languages, for example, Python, it's not that easy to switch between different versions. Or maybe we don't want to install that version on our PC. So let's say that, for example, we want to use different versions of Postgres, 10, 9, and 12, because we are working on different projects at the same time, and this happens kind of often. This might be a bit hard. So by having this local development environment, it would be nice to have them in separate environments. And this happened to me also some years ago. And of course, we don't do a slide like this. So for virtual machines like this, we have this full-blown operating system that runs on top on an hypervisor. And this is not wrong, But of course, usually there is some overhead, and also the spinning time usually it's minutes, and it's a bit slower. It requires more memory, and so on. They still have some use cases, of course, but for most applications, having an architecture like this might be, I would say, more lightweight. So of course, also less expensive. And yeah, let's go faster here. So Docker uses these client-server architectures. There are something called Docker objects. Maybe you heard all of them. We'll go very quickly through all of them. Images, containers, networks, and volumes. And the client talks to the daemon server, which manages these Docker objects. And the client and the daemon, they can be on the same system. For example, when we run Docker for the first time on our Docker desktop application, or they can also be used by remotely by using HTTP. And the connection is done on the REST API and Unix. And yes, I stole this from the official Docker documentation. And also the Docker client is the main way to interact with Docker. And when we run some commands, Docker run, Docker ls, the clients sends these commands, and then they are managed by Docker daemon. And of course, it uses something called the Docker API. What are images, quickly? The images are these read-only templates, and you can use existing images. You can create your custom one. This is what we will do today. You can even technically start from scratch, but it's very, very rare. Honestly, I saw this just during tutorials. And on top of an image, you can run Docker containers. Docker images, we will see this process hopefully today. We'll start with a text file, then we create this Docker image with a command called Docker build, or we can also use Docker Compose that we'll see today. And this text file, I think it's very elegant, and it helps to create almost one layer per instruction. It depends on the instruction, to be honest, but we can consider this like one layer per instruction. And every time, and also Docker uses this system of caching. So usually when we build an image that has some small differences, it will be easier to build. Okay, and so a container is like a process, and it has its own dedicated file system that is provided by this image. And the image is not just the code. The image has dependencies, configuration, the environment variables. We have an environment variables today, for example. And of course, we need to remember that we can run multiple containers from a single image. About a Docker network, containers need to communicate each other. So there are 5 main ways to communicate each other. The default is the bridge one. It's almost invisible. When we run Docker the first time on our machine, we don't even know about that it's actually running on a bridge network, and it allows the container to communicate each other. Even when we run, for example, Docker Compose app, it creates under the hood a bridge network by default. We can have a host network that removes the isolation between the container and the host machine. Overlay that is done basically to enable Swarm services, like Kubernetes services too. MacVlan, I haven't used that much, but it's used for legacy applications. For example, if we want to use just the MAC address. Does anyone ever use this MacVlan network? I keep asking for this on every conference, and I always get a 0. And also known, if, for example, we want to have a tool to just disable networking. We don't want it, and we want to do things, for example, manually. About persistency. Persistency is a problem that we didn't have before containers, because on virtual machines we have persistency by default. Instead, with containers, we need to find a way to have persistency. There are 3 main ways. One is the preferred way is to use Docker volumes, this one. They are managed by Docker, and they are also used in the same way across different operating systems. And another one that is also used, especially in development, is bind mounts, when we map a specific directory or files on the host. And this is, for example, is very useful. Classical example and use case, if we have an app.config file and we want to read the configuration of the application while it's running. But for example, this might be different, because also we know that the path is different, for example, from Windows, Mac, and Linux. So we need to be careful with these bind mounts. Another one is TMPFS mounts to store data in a region of memory which is not persistent. Usually this is used for sensitive data caching. We can also use something called secrets, but this is just to have a test, okay? Okay, now, so this was just an introduction to a couple of technologies. Now we will see the project. I've used Actix. Someone has ever used, did someone ever use Actix as a Rust web framework? No one, perfect. Okay, so I think we can check the project now. Okay, so can you see? A bit bigger? Okay, maybe like this. Okay, so this is a Rust project, and we have, for example, this cargo.toml file. Tom stands for Tom's Obvious Markup Language. This is similar to package.json or requirements.txt. We have this package here with the name, version, and edition, but here I'm more interested into the dependencies. So we have Actix Web, which is the web framework, Actix Files, which is to serve these static files. We'll serve very simple index.html and other static files. We have Serde, which is used for serialize and deserialize objects in Rust. Serde_JSON is to specific JSON format because we need to make HTTP requests. .env has the same name of the npm one, but of course it's not the same one, but it does exactly the same thing. And request, it's not a typo, it's called a request, and it's used for making HTTP requests. Okay, nice. Let's check the other files. Here in the static folder, we have a very simple index.html that has just just a drop down of languages, because you remember I want to do basically live translation captions. Okay, so I need to choose from one of them, from and to, and this is very simple. We have just literally a couple of buttons, just one to start and one to stop. We'll see this in action soon. We have a style.css which is empty, so this app will not look good. And, and here we have an app.js file. Here, to recognize my voice with the microphone of the laptop, I'm using this WebKit speech recognition library in JavaScript. Everyone ever used this? Okay. Okay, so this is very basic. Probably we can do something better here. But basically we are using just having this recognition. And here we have some functions, for example, on start, on result, depending on when we are listening to the person who is speaking. We have a problem on error. I hope we will not see this, otherwise we'll see this error. And something interesting is this one. So this will work as a sort of front end, and we'll have the backend in Actix that we'll see soon. And here we have this /API/translate endpoint. We'll see what we'll do here. This is a post request, and this is basically stringifies this source language, target language. Here is a tone. I have hard-coded informal because at the end we will see something. And at the end we have just these languages. Okay? So now it's time to see some Rust code. Okay, we still have some time. Okay. Okay, so let's start from here. Here we have all the imports of the dependencies that we did, we saw before. Then we have here a struct. It's basically like an object in Rust. And here we have text, the source and target language, the tone. So, and you see here we have this deserialize because we want to deserialize this struct. And as an answer, so from the server, we will get just a string. Just we want to get this answer just as a string. Okay. This is interesting. This is the function to make the translation. So we are using the OpenAI API key, which is inside this .env file that I will not open, of course. And here we have the translation prompt. And this is basically all our AI application. It's literally just this single line. So we are doing this prompt to ChatGPT, and then we are getting an answer. Okay, so it's a mix between our microphone and making this under the hood OpenAI API request. And here we can see the response. You see here we are doing the request to OpenAI. We have the header with the authentication, the JSON. We are using just this GPT 3.5. To be honest, for this example is fine. It works so far. And then we do send and await. And then I see here one of my favorite statements in Rust, which is the match statement. Huge fan of this. Match is similar to a switch on steroids. We can consider this like this. And it's basically used for pattern matching. For example, we can use a match statement directly with an HTTP response, which is great, for example, compared to just native types or integers or strings. And inside this response as a type, as a result, that can be a response or an error. So in case of error, we'll go here. Usually get this when I get some internet connection issues. Otherwise, we have here, instead of OK, we have another match statement, depending in if we get a proper answer or not. Usually, I get an answer if I get inside this OK. Then we have this function just to serve the index.html file. OK, and here, I see something that probably if you ever done an application using Express in Node.js, you might find sort of familiar, because we have this main function, .env.ok. This means that it's basically loaded the .env file when we have the OpenAI API key. And then we create this request client. And here, as you see, very similar to Express, so we have this app new, and then we add this request client, and then we add the translate route, the index route, and the static files route. Okay, and then we bind it to 0.0.0, and the port is 8080. Okay, here we have run, and here await. So I think that now we can make a test, and okay, and as a test to run the application, we can type cargo run. Okay, let's go here like this. Localhost 8080. Okay. And we have this beautiful application. Can you see it? I think a bit bigger. Now this is the moment of truth. So let's switch this to Greek. Ok. Provo a parlare in italiano. Riuscite a capire cosa sto dicendo? Okay, this is a demo for, and basically I'm translating from Italian to Greek. Now it's probably going crazy because I can. Let's try the opposite. This is hard. Kalimera. It worked. Okay, so this is basically. Thanks. Okay, so let me stop here because. Okay. So, and of course, this is just a prototype, this is just a beta. So the idea is to have something similar to this. So live captions while I'm speaking. So this was my core idea. By the way, of course, the project is open source, so you can check it out. All the code is available, and there's also a surprise at the end. Okay, let's check the Docker part now. Okay, because we talked about Docker. So we have this application done in Rust. Okay. Now let's say that we want to put this inside a container. Okay, so how can we do this? First of all, I want to stop this. So okay, so as I said, to create a Docker image, we need a Docker file. So this is very simple, and of course not production ready Docker file, but just to give an idea. So we start from not from a basic, not from scratch, but we start from a version of Rust, for example 1.72. Then we have this workdir command that creates a folder and path, and then it also uses many upcoming commands inside this folder. This copy dot, I think you will see a lot this around if you play with Docker. It basically means copy everything which is inside this folder where the Docker file is inside the Docker image. Quick note, we have a file called .dockerignore that works exactly like almost exactly like a .gitignore. So for example, if you don't want the target folder to be inside the Docker image, we can remove it. And also, fun fact, a Docker image doesn't need the Docker file inside the Docker image. The Docker file is just used as a set of commands to create the Docker image. We can expose this port 8080. This is just for humans, to be honest. And then we can just, in this case, just run this default command. When you see cmd inside a Docker file, it means that this will be the default command run when we will type docker run. Docker run translates into the basic cmd command. Okay. Now, to build an image starting from a Docker file, we have two options. One is to type docker build. In this case, I want to do something a bit different. I want to do this with a compose.yml file. So instead of typing directly docker build or docker container build, I use compose. Docker compose, it's basically two things, just to make it easy. One is CLI commands, so I can type docker compose something. And one is also a compose.yml or docker compose.yml file. In this case, we are reading the compose.yml file, which I think is the default one now. And here we can define some services. In this case, we'll have just one service called Rust app. Rust app is the name of the service. We can have a default container name, a default image name, and in here we have this build dot, that means build based on the Docker file which is in this path, in this folder. This is why we will see Dockerfile and Compose YML often at the root level. And here we have ports externally and internally and as 8080. And here as env file .env. To be honest, if you remove these two lines, it will work because by default, I think that Compose checks if we have a .env file. But here, to make it easy, I prefer to leave this. This is more explicit. Okay. So now to build this image, I can type docker compose build. Usually, we can also do directly docker compose app. I prefer to do this in two steps, so in case I have some errors, it's easier. But I can also just do docker compose app. Okay, this was fast because I had some level, some layer already cached. And now we can type docker compose app. Okay, and here we have the same application, but now the same application is running inside the Docker container and it's exposed hopefully on port 8080. Let's see if we are back online. And yes, we are back online. Okay, so for example, Italian English. Grazie per avermi invitato qui in Salonicco. Okay, Salonicco is the Italian name for Saloniki. Perfect. Okay, so but this time we were using a Docker container. Okay, nice. Okay, so we saw this project. This project is available, and this is all done with Rust and Docker. Now, before we leave, I want to have like 5 minutes for questions. Where are the? I think it's here. Okay, we were here. Okay. Okay, so before we wrap up, I would like to show you something here that I have, like this. So this one. So basically, I spent more time for the CSS for this application than for the whole presentation. So, and this is live and deployed, so you can also play around with that. And here I made some small changes. Of course, we have dark mode, white white mode. We have a link to DailyDev, which is the company I work for. Here you can choose the language. It's more usable. You can also access from this from the phone. I have a QR code later. Let's make one final test. It's actually deployed. Let's try again. Ok, questa è la fine della presentazione. Grazie mille. It worked. Okay. Thanks. Okay, almost done. Just because I want to leave the QR code here. Yes, we are perfect timing. So this is in beta, but you can try it out, okay? But no worries, you can use it. My CEO will cover any cost for any use of this OpenAI API key, so no worries, I'm not paying for that. And can I change? I have also the QR code also here. And if you have any questions, just let me know. And thank you so much. I really love this city. This is my first time in Greece, and I think I'll be back at some point. Thank you so much.
Yep. Cool. Thanks, Francesco. Thanks a lot. So we have time for questions.
Okay.
Please go ahead. No questions? Okay, no questions. I think it was very well put together. That's why it was a very good presentation about Docker.